So hi, my name's Jenny, and I'm going to be talking to you about SCADA system security. So I'd like to preface this by saying that since I signed up for the talk, a lot's happened, some good news. It's resulted in me changing my jobs and obtaining funding ready for my PhD, which I'm going to start in January. So it means that I've been spending more time getting my proposal ready than preparing for this talk. So my apologies, I will be reading, but I hope you enjoy it. And I prefer to do my best than to cancel. So thank you for coming. So let's start by rewinding back 6 years to the end of my second year of my information security bachelor's degree. So quick shout out, you don't need a formal education to work in tech. That was my route, but it's not the only one, and I'm a massive advocate of that. Anyway, I was weighing up my options for my dissertation. The two areas of cybersecurity that had especially piqued my interest due to two pieces of literature were SCADA security and mass surveillance. So the literature was a book called Data and Goliath, which I imagine some people have read, and a Chatham House report on cybersecurity at civil nuclear facilities. So I was aware of mass surveillance, and I'm sure everyone here knows who Edward Snowden is. But I wasn't aware of just how much was happening, and as a 20-year-old reading this book, it was eye-opening. To this day, I don't believe I've shared my opinion on mass surveillance, starting from a class conversation in first year when I was picked on by a lecturer to answer the question, Edward Snowden, hero or traitor? And my answer was, I don't know, but he's hot. So I didn't have enough information to answer the question, and now I see I answered like a true politician. Such a complex area, and it's almost dangerous to share our opinion on it without a thorough explanation, especially as it's easy to see it from both sides, or it is for me. This talk isn't on mass surveillance, as you can tell, so I didn't go down that route, but the Chatham House report was just as shocking for me, but in a completely different way. I wasn't aware of the technical issues faced by SCADA systems security engineers, and in this report was my induction into what exactly a SCADA system was. It explained that these nuclear facilities are or should be air-gapped, which means they're not connected to the internet, and that updating them is really difficult as downtime is needed, which for an electricity grid can be difficult because you have to take the electricity offline. So this had alarm bells ringing for me, and I was thinking, what if there's a vulnerability that needs to be patched? How can it be secured? So obviously they should be air-gapped, so this shouldn't matter, but that isn't always the case. So these interests led to two options: the ethics of mass surveillance by nation states and the security risks associated with SCADA systems. The first option would be a literature review, and would be difficult for several reasons. Firstly, to get ethical approval, it would need to be thorough and look at both sides and include research of how the surveillance impacts people. This in turn would make the evaluation phase very difficult. Not only that, it would have to come across as completely unbiased. So the second option, SCADA systems, was technical and tangible. I could look into how known attacks have happened and look at creating something to reduce the risk of those attacks happening. I could then get the product created, evaluated for effectiveness, and I've got a solid idea for a dissertation. So as you can imagine, I went for the dissertation looking at the security risks associated with SCADA systems. The next step was to figure out what I'd be creating. So prior to writing up my dissertation proposal, I did some research. By now I was in the beginning of my third year, so I needed to get my idea submitted and accepted soon. So the initial research showed that a lot of attacks on SCADA systems were successful due to human error, so I decided to focus on the human factor of cybersecurity. The first step to resolving this would be to put measures in place to educate those with access to the systems and restrict unauthorized access to the systems. I decided on a compliance-based topic where I would create an information security management system for use with SCADA systems. The dissertation would have two halves. Firstly, a literature review of articles about current known attacks. This would include a brief a brief introduction to SCADA systems, and the dissertation had to be written with no assumed knowledge on the part of the reader. A detailed review of several SCADA system attacks and a write-up of my primary research where I interviewed SCADA engineers over the phone. The second half would be documentation of the process I underwent to create the policy document, referencing the actual document in the appendices. This included analysing a large number of existing policy documents, focusing heavily on the ISO 27000 series. I looked at policy layout, content, and writing style. So, for those in the audience who don't know what a SCADA system is, this is for you. SCADA stands for Supervisory Control and Data Acquisition System. And the best example I have is a thermostat linked to central heating. You set it at 23 degrees C. It takes in data and makes changes accordingly. If the temperature is 20 degrees C, which is below 23 degrees C, the heating will be on. While if the temperature is 25 degrees C, the heating will be off. If the heat rises from 20 to 23 degrees C, the heating will click off. While if it falls below 23 degrees C, it will come back on again. Here's where industrial control systems, especially critical national infrastructure, comes in. A nuclear reactor's temperature is regulated this way using control rods that control the rate of fission. A nuclear reactor works by heating water using the heat produced by the reactant nuclear materials. The water evaporates into steam and turns into turbines creating electricity. The nuclear reaction has safe levels, and the data acquisition of the temperature and the correct use of the control rods is imperative. Just look at Chernobyl. There may be some human intervention here. I'm not 100% sure of how it happens, especially now. But when the reaction gets too hot, more control rods are added and it's cooled down. So incorrect data or malfunctioning control rods could be catastrophic. So for security reasons, critical national infrastructure should be air-gapped, which means that they should have no connection to outside networks, especially the internet. But the original SCADA systems were monolithic, not because of security, but because of when they were built. Monolithic SCADA systems are made up of SCADA master connected directly to remote terminal units. They're completely air-gapped. From here, SCADA systems grew a technology with distributed SCADA systems using a local area network and a networked SCADA system using a wide area network such as the internet. So I won't insult the older people in the audience by explaining these, but if any of the younger members want me to talk about it, catch me afterwards. Finally, we get to the Internet of Things, which is relatively new, and we go back to the thermostat. Because thermostats, which used to be a monolithic SCADA system, are now part of the Internet of Things, as you can control them from anywhere using technology such as Hive. While someone hacking into and messing with your thermostat could be a pain in the ass and cost you a lot in energy bills, especially at the moment, it's nothing compared to what can happen if someone hacks your national grid, and sadly my case studies include just that. So my literature review included 10 case studies. These were David Best, Sobig, Sasa, Conflicker, Stuxnet, the Worcester Air Traffic Communications, Night Dragon, Marucci Shire oil spill, Zatterworm, and the Ukrainian power outages. Today I will talk about 3, but if anyone wants to hear more about the others, I am happy to share the full document. So over a 3-month period in the year 2000, between 800, I think it's 800,000, but it might be 80,000, sorry. Over a 3-month period in the year 2000, between 800,000 and 1 million litres of untreated sewage was released into storm drain water where it leaked into local waterways. From the waterways, the sewage reached local parks, rivers and property of local hotel. And this was in Queensland's Sunshine Coast, Australia. So this caused the death of marine life, the water turned black, and an unpleasant smell lingered in surrounded areas. One day within the 3-month period, which was the 23rd of April 2000, the attacker gained access to the public distribution system by logging in at one pump station. With this access, the intruder sent messages to corrupt the system from the said pump stations. These messages disabled alarms to alert staff of faults at 4 pumping stations. Using a laptop and a radio transmitter, it had been claimed by the IFIP that the attacker managed to control 150 sewerage pumping stations. The attacker gained access just after 7:30 in the evening and concluded after 9 in the evening. It supposedly took him at least 46 attempts to gain control of the sewage system. So it turns out that the person who did this was somebody who had applied to work for the company they attacked, and because they were rejected, they did this as revenge. So he was arrested in his car, and it contained all the equipment needed for the cyber attack. And on his laptop, he had software that had the ability to communicate with the PDS in a sewage plant. So it's been confirmed that there wasn't any existing documentation, such as an information security policy, or any security procedures in place at the time. So the next one I'm going to talk about is SCADA. So on the 1st of May 2004, the computer worm SCADA made an appearance. It exploits CVE 2003-0533. So it's a vulnerability that Microsoft has released a patch for on the 13th and 28th of April 2004. So this emphasizes just how vital patch management is. So, SCADA infected many organizations, including British Airways, the Maritime and Coast Guard Agency, American Express, the European Commission, headquarters in Brussels, Delta Airlines in Atlanta, and it caused 7 hours of damage, causing 40 flights to be cancelled, losing finances to the company and inconveniences to customers and the rail corp, who had to stop trains from running due to lack of communication between drivers and signalmen. So the worm was first discovered when it exploited a buffer overrun with the local security authority subsystem service process. So to gain remote access to an XP or Windows 2000 system, the LSAS vulnerability is exploited. It supposedly uses TCP port 455, so an SMP port, and its way onto it uses the port 445 as its way onto computers, which is an SMB port. It's been claimed to use port 139 by some Microsoft researchers, however. So once it gains access to the computer, it then starts 128 scanning threats to find vulnerable systems that are networked to the host computer. From that computer, vulnerable computers are then probed at port 445 to spread the worm. So this went on a long way, and SCADA was written by a 30-year-old German who is now a computer science graduate called Sven Jackson. When he coded the worm, he was 17 years old. So he's not 30-year-old anymore. He's got to be 36 or 37, because I wrote this 6 years ago. So he was arrested just days before his 18th birthday and avoided being trialed as an adult. So the last one is a bit of a difficult one to talk about because of what it's turned into. So the Ukraine nuclear power plant outages. On the 23rd of December, the Ivano-Frankivsk, I hope I said that right, region of Ukraine lost power due to a cyber attack against 3 known regional power distribution companies. So there are several steps to the attack. Reconnaissance was carried out in the form of spear phishing to gain access to the business networks, and black energy was found on all of the networks attacked. It's a possibility that the spear phishing energy contained the malicious payloads, black energy. So I haven't actually looked into this since then. I imagine there's more details on that being confirmed now. So once the once the access to the network was granted, credentials from the business were stolen. VPNs were used to enter the ICS networks, and remote access tools used for the SCADA systems were then utilised, which means the attackers had remote access. So this didn't only happen once. While I was writing my dissertation, there was a second attack on Ukraine. So on the 17th of December 2016, just before midnight, an area of Kiev, the capital city of Ukraine, lost power. The power outage occurred less than a week before the anniversary of the previous attack. So as you can imagine, back then everyone was pointing fingers at Russia. And I believe I have a quote from what I wrote in my dissertation. So with Russia and America's current relationship, if Russia is behind the attacks, it could be assumed that America is at risk of a similar attack. Kiev only lost power for 45 minutes. However, it's been suggested that because America's grid is so advanced and fully automated, it would be a lot harder to fix, so people would be left without power for days. So the issue is that we now know that these were prerequisite for the conflict happening at the moment, which is really sad. So next I'm going to go on to the primary research I did, and let me just check the time. Okay, so primary research was a success in gathering information that was needed. However, it was not possible to find out the downtime necessary to replace the SCADA system, as a consensus is that the actual systems are not the main risk, but the personnel uneducated in security are. So having an ISP in place and enforced is the next step to increase in the security of SCADA systems. So I spoke to 3 people, and I'm going to talk about them now. So the first person I interviewed was an ex-employee of the company Unilever, and he had worked there for 27 years as a SCADA developer. So he began working there. The process to manufacture the product, Wall's ice cream, was manual, and over the years, automation, data monitoring and analysis were added in the shape of SCADA systems. So it was fascinating hearing about how him as a control engineer was the one who introduced the SCADA system and automation over the years, and eventually it became a networked SCADA system with a connection to the World Wide Web. So I asked him several questions, including whether he saw a risk in being connected to the internet, whether they had information security policies in place, whether the policies were enforced, and whether they had a data recovery plan. He shared that he hadn't considered the risk of the factory being hacked, and said that the company would lose a lot of money should the temperature controls be meddled with. Well, ice cream would melt everywhere. So as it happens, they did have security policies, but mainly for the business systems and not specifically for the SCADA systems. They also had disaster recovery plans. However, if the policies didn't cover the SCADA systems, I can't be sure how good those were either. It was an interesting conversation, and it solidified the need for SCADA-specific policy documents. So the next one I'm going to talk about is someone who worked at Caterpillar in Vanderland as a SCADA developer. So the first question I asked him was whether the company had any ISPs, information security policies, to which he said there definitely was one at Caterpillar, as it was demanded by management, but at Vanderland he stated that there were none in place as far as he knew. So he justified this by saying the automation was kept off the internet, so it was air-gapped. One quote I included in my write-up was, "If you want my honest opinion about security with control systems, I don't think it's considered at all by anybody. It's the last thing on anybody's mind." He said that if he has remote access to the system, then there's a way for attackers to get in. So he always thinks SCADA systems should be air-gapped. Once again, I had convincing evidence that security policies and procedures in SCADA facilities are lacking, and that the document I was creating was needed. So the final person I spoke to worked at the National Grid. So I was happy to hear that the National Grid is very secure and the company takes information security seriously. They change all of the off-shelf products' generic passwords and usernames, and use a third-party IDS supplier who also supplies internal training and business support should the SCADA engineers need any help. So this was 6 years ago, and I imagine things have only got better since then. So the network analysts get basic network intrusion detection, where they'll be able to recognize traits of things like buffer overflows. Anybody who asks for security training gets it. So well done, National Grid. So there were not specific policies for SCADA, but he knew SCADA was mentioned in the generic information security policies. He spoke to me about making sure that each person had the correct level of access and the principle of least privilege. We spoke about patch management and about how patches would need to be tested before being implemented. He explained that the risk of a vulnerability being exploited before the patch and the risk of a new patch bringing down the system needed to be weighed up very carefully. I was definitely impressed with the responses, and this restored my faith in SCADA security. It was an example of how implementing and enforcing policies with the correct scope can decrease the risk of a successful attack. So the next one I'm going to talk about is a conversation I had with my own granddad. So he wasn't named as my granddad on my dissertation, I named him by his name. But I spoke to him about the SCADA attacks that end up on the news. And as someone who has a news channel on all day, he had some really good comments. And he's in his 80s, and he's unable to use a mouse. He literally can't use a computer. But he could see just how bad these were. And a quote from him is, "Surely they should be able to do something about it. And surely we should." And over the past few years, thankfully, the industry has been doing something about it. So, to create the information security policy documents and the ISMS, I looked at existing documents such as ISO 27001 and 27002, which I had access to through uni, thankfully, ISA 99, and Sandia National Laboratories. I looked at a lot more than that. I probably looked at about 50 different policy documents from companies that shared their policies online, and there was one specific university that had really good security policies, but I can't remember their name. But if anyone wants to know who they were, just pop me a message and I'll find out. So using them, I took the best practices and I put all the best practices together into a document that would be ideal for SCADA, pretty much. So I did explain it in this, so this is a quote from my dissertation. So it's pretty much what I just said. So I'm happy to share the slides, but that's the quote from my dissertation. But I have just said it. So the sections included the purpose, scope, structure, organizational information, data security, interested parties, the ISMS, access controls, platform security, communication security, personnel security, system updates, auditing, applications policy, physical security, manual operations policy, incident management, information security continuity, redundant employment, and revision history. So it was a massive document that was at the back of my dissertation, and to this day I'm still really proud of it. In a longer version of this talk, I would go through each section and how each section applies to SCADA security. So if I do that in the future, I'll make sure to share it. So as I mentioned earlier, I had aimed to educate those with access to the systems and restrict authorized access to the systems. So I felt like the document managed both of them, but I needed to get it evaluated in order to pass the dissertation. So I'd met someone on LinkedIn who kindly offered to look over the document and give his feedback on it. He is a security engineer, and to this day we've actually become quite good friends. I barely knew him at this point, but he's one of my best mentors. So was I successful? So to quote him, "The ISP has been thoroughly researched and all the section headers were valid. However, as the document was written by a novice, there was jargon that should have been used in certain places that wasn't originally known about. There were also specific ways policies are expressed within the industry that were not followed, such as the word should being inappropriate for a policy document, as the word must is more appropriate. To give a final evaluation of the ISP document, I just went into my write-up then. So my friend Andrew wrote, "Having reviewed the SCADA information security policy, it's clear to see that Jenny has researched some sensible conclusions has reached some sensible conclusions and has researched this topic, taking into account the rapid recent change of SCADA systems and their surrounding technology. The policy has the hallmarks and structure of a robust and prescriptive information security document. So I'm quite proud of that, especially for a 21-year-old. Looking back, all I can see is issues, but I'm still proud of it. So there's a chance this will actually link to my PhD. So I'm hoping to look into whether products out there are actually good for companies and what their efficacies are. And I do want to focus on SCADA security. So I'm yet to get my proposal accepted, but I'm hoping that it will look at that. So what I hope you'll take from this. So compliance plays a large part in mitigating cybersecurity risks. Cybersecurity is a sector where you can make real-world contributions. Like, just think of the Ukraine stuff. And shout about something when you do it, not half a decade later, because I really should have shared this policy around when I wrote it. And I'm really glad that there are other things like this out there now. But I feel like this could have been used and saved some people some time. So I should have shouted about it. So thank you so much.
Thank you very much for that. It was really interesting. Do we have any questions from the audience? Because I have one question for you. I'm going to stand over here so people can actually see me. Do you think that we've seen an improvement in the SCADA security systems that we have? Have we actually learned, are you seeing any evidence that we've learned lessons and you feel like actually we are improving, learning lessons from these sorts of attacks that have happened? Or are we still kind of batting our head against the same wall?
So especially for critical national infrastructure, there are requirements in place now for them to be secure. I believe back then the National Grid were keeping their systems secure because it was the best thing to do and not because they were told they had to. While now there's a lot in place, companies have like IoT secure certifications. I think we're going in the right direction. A lot's happened in 6 years, and if I had more time, I would have loved to touch on that.
And obviously, like if you're looking at critical national infrastructure and you're looking at power stations, you can see the drive, I guess, for the government to put in place things that would make them more secure. But what about things like farms that would use SCADA security, but perhaps wouldn't have the drive of the government and policy behind it to sort of say, you need to secure this?
I think without funding from the government, they're not going to do it. I know that there are funding grants out there for smaller companies to become more secure. I'm not sure if there are any SCADA specific ones, but
because it's everywhere, right? So that's the problem. It's okay for critical national infrastructure, but if it's proliferated outside of that, we could still have the same problem.
I'd be interested to see what Unilever Walls is like now, whether they've got anything in place.
Yeah.
Because the guy I spoke to, he didn't work there at that point. He worked at another company. But he was shocked when I said, well, what would happen if someone hacked in? He was like, oh, I'd never thought of that. He worked there for 27 years and never thought of it.
Yeah. Yeah, it's got a big change to happen then. Well, thank you so much for that. It was awesome. Love the talk.